Hi, my name is Lisa Richter. I'm the Director of Industry Outreach and Growth for CSIA. Welcome to this masterclass. Before we get started, a quick word about CSIA. Probably most of you here today are familiar with the association, but if you are not, all you really need to know that it's CSIA's mission to help system integrators build better businesses. How do we do that? Well, for starters, we have a team of volunteer system integrators who crowdsource a best practices manual to help SIs scale their businesses. In fact, the BP manual released the latest version about a year and a half ago, and they are already planning and working on the next version. CSA is also about to launch a new learning hub, which is a way for our members to help their team members get up to speed quickly with system integrator specific courses and training around the business that we think will be super helpful for our members. CSA also offers a certification program and other resources, including professional development, learning from peers, and access to professional services like insurance and legal and finance, who really understand the SI's unique business needs. For our partner members, CSA offers an ecosystem to grow your SI programs, understand your customer pain points, monitor industry trends, and share your thought leadership. With thousands of qualified integrators and suppliers, the CSIA Industrial Automation Exchange helps system integrators, industry suppliers, and end users connect and do business. For system integrators and partners, it provides a platform to support your content and SEO marketing efforts, position yourself as a thought leader, and nurture prospects during their complicated buyer's journey. If you are not currently a member, now is a great time to join. Membership provides you and your entire team a full lineup of virtual events and other resources from accounting to sales to operations 365 days per year. It also means you and your team can attend the CSIA conference because this annual in-person event is members only. A quick word about the conference. If you are attending, the welcome reception will be on the Tuesday evening, and it's kind of a beachy theme. So a reminder to pack your Hawaiian shirt, or as like my boss likes to say, your loud shirt. We'll see what happens. If you want to just get a flavor of CSIA and its members, I encourage you to listen to the Talking Industrial Automation podcast. CSIA members talk all things industrial automation, and it's a great way to hear what your peers are up to. One last housekeeping note before I turn it over to today's speakers. If you have a question, please use the Q&A feature in Zoom. That just helps us stay organized. And the session is being recorded, and you will get a link to a recording in the next few days. At this time, I would like to turn it over to today's speakers. Take it away, guys.
Thank you, Lisa. I hope you can see my screen.
Yep, you're good.
Thank you. So, welcome from our side as well. We wanted to focus on these emerging technologies and specifically bring in a perspective of a system integrator on these technologies. So, I am together joined with Timothy Triplett, President of Coherent Technologies, who will join me during this process and share with you his inputs of the project and the perspective there. Going forward, I would like to emphasize that we will talk about OPA, Open Process Automation Forum, the Texas A&M project. That's where Timothy takes over and why they selected an OPA system. I will then step in again with the focus on the IS-1 plus and the focus that it can be used in the classified areas, in the hazardous area. And then Timothy will again provide an input on what the current status is, and then we can have a Q&A. So what is Open Process Automation Forum? This is a forum, as you can see up over here, lot of the end users, a lot of the vendors, and now a lot of the integrators have joined to come together to put forward this technology. It is a industry. It's a part of developing an industry standard, which will be based on the current standards, so that you are adding on and improving on what is already available, but ensuring that they are interoperable and they are meeting up to the requirements of the OPAS standard. So this is the typical architecture, what you see over here. It is comprising here of the OPAS products itself, but in the blue, what you see here are your legacy devices or equipment, if I can call them, and then you have the relevant gateways which will allow you to communicate to the OPAS connectivity framework. As I mentioned earlier, this is a standard of standards. So we are working with a lot of standard development organizations, the OPC foundations, the DMTF, and various others, where we are working with them to update, improve, add on, add value to that, and develop and integrate those standards into an overall open process automation standard. Today's ecosystem, you have the automation vendor, could be a PLC, a DCS, and then a system integrator like you, putting together the solution based on the end user, your customer, our customers' applications. Your expertise of the industry, of the equipment, your expertise of the processes to implement and execute, which is also a very important part of the expertise you carry, and then even the possibility to maintain it over a period of years. So this is your current ecosystem, and what OPAS is trying to do is build up something very similar. You are still in the middle of the game, but then you have separate hardware suppliers and software suppliers. Part of the story is that you will be able to have an interoperable system, and interoperable systems would give you the flexibility of using multiple hardware vendors and multiple software vendors. It also gives you the facility that you would be able to use softwares and then port the applications you have developed from one hardware to another. So a lot of the capabilities are brought in by these two vendors segment. Now, it is not necessary they need to be separate. They can be all one. You could have the hardware vendor also providing the software component as well. And then as an integrator, you are implementing it down the way and installing it at the end user's facility. Service providers basically are providing these service from a product lifecycle perspective. You are providing support during the operations at the plant. So that could be another role which is part of the ecosystem which you could be implementing. How are we developing the standard? The ecosystem. You as a system integrator, the vendors, and of course the end users. You all have user stories, you have experiences with your current installations, and you are wanting a change, you want something different. What are your expectations? You would be building it up and sending it over to OPA over user stories. We can develop use cases out of that. And probably then even a system integrator is providing a use case, or even the vendors are putting up the requirements. All of these boil down into the standards. They are being discussed, they are being evaluated, and then they are being also generated as profiles, as certification requirements, and then they are being implemented into a standard. So that is how the industry voice drives the OPA standard. We would welcome all of you all to join us in this role. If you all want to join OPAF, uh, contact me. You'll have an email ID down the way where we can then get you connected to the right person in OPAF. Standards are going to enable functionality. What you see right now is the standards which have evolved over the period of some 2017, if I remember correctly. First version was with interoperability, then was the base configurations, function blocks, configuration portability, and then these are in the works as of now. Application portability, orchestration, physical platform. So it's an evolving standard. Is it done? No. Is it ready to be implemented? Yes, the version 2.1 is ready for you to implement a testbed, is be ready for you to implement a pilot project and even actually commercialize. This is what we are going to show you, a commercialization of the project. So that is the workflow that we have within the forum of what we have to do to finish the standard. Of course, it is a continuous improvement project, so we'll keep on updating, improving as what we learn from these implementations and what we need to adapt and improve. COPA. So OPAF is a standards development organization. OPAF will not go out and market. These are the OPAF members who have come together to market the OPAS-based solutions. So together with Seaplane, together with Collaborative System Association, with currently these integrators, Wood, Eosis, Burroughs, and others, and then the component suppliers, we are putting together industry-proven devices along with the capabilities of system management of Seaplane and CSIA, and then also the system integration teams which are there. Again, you're most welcome to join the COPA group. You would be able to then take the active role in developing solutions for your test beds and then also for your customers. It was, of course, built on the open standard, the OPA standard. It ensures high availability applications. Definitely, it is intrinsically secure, capable of remote management, and then the cost factor, which is the most attractive, is not only the cost factor at the time of your capital purchase, but also as a total cost of ownership. You will see definitely a lot of savings there. Texas A&M project. This is the first commercial project from COPA, and I will let Timothy take over here and
Okay, thank you, Ravi. And
explain
if
to
we
you.
can, all
Timothy,
right.
You have control.
Okay, very good. I appreciate that, Ravi.
Sure.
And I would like to advance to the next slide now. And I am trying to do that. There we go. Okay. Yes. So this project is for Texas A&M Nuclear Engineering. They are ranked #1 in undergraduate nuclear engineering programs, #2 in graduate nuclear engineering programs. It's home to one of the largest university research reactors. It has a strong partnership with national labs, Department of Energy, other industry leaders, and well supported by the state of Texas. They have formed an advanced Center for Advanced Small Modular and Micronuclear Reactors under the Texas A&M Engineering Experiment Station, with the goal of advancing the nation and the state's leadership in advanced nuclear technology. As a part of their ongoing research, they are investigating control technologies to facilitate the deployment of small modular reactors and microreactors. And why now? Because nuclear has been around a long time. Why now? There's if you'll switch to the next slide there, Ravi, I can give it a try, but it doesn't seem to like there we go. There's some diverse and challenging environments out there. One, remote power, when in areas that, that are not available to the grid. Military applications where you need power, secure power in an area that just doesn't have power now. Emergency response, a hurricane wipes out the power sources in, say, Haiti or someplace like that. A small modular reactor could be quickly deployed to that location and reconnected to the grid to restore power. AI data centers. I'm sure this hasn't missed your attention that AI is a massive hog of energy for the training centers and such. So those the companies that are putting up these multi-billion-dollar projects would like to have the power source right next to them, so they don't depend upon the grid and other systems that they don't have control over to provide power for their data centers. The microreactors are particularly useful in space exploration, where you need something that has that compact form factor, easily transported, reliable, long lifespan, well over 10 years without refueling. All of that is really very attractive for space exploration also, which is accelerating along with the AI. So there's a definite need for the for nuclear power, particularly small modular reactors that have gone through sufficient training, testing, evaluation, as opposed to the old way our industry in the United States first started off with. Each nuclear power plant was huge and custom. And so each one had to reinvent the wheel. But with small modular reactors, you've got the design worked out, and if you need more power, you just put in more small modular reactors. So you just increase the number of them. It's like having, instead of a 1-cylinder engine, now you've got an 8-cylinder, a 16-cylinder engine, each one contributing equally to the mix, which also increases reliability and lots of other positive factors. So the future for nuclear power is going to be in a small modular reactors. And let's see if it'll go next slide. Yes. Okay. So A&M, part of their objective is to because the small modular and micro reactors are going to be oftentimes in locations where there isn't a large staff to support it, to train it, to operate it and such. There's a need for autonomous control, for remote management. And of course, when you start talking about remote management, especially now cybersecurity becomes a critical factor. So their objectives were to answer these challenges, to be able to remote management, autonomous control, and cybersecurity. So if you'll advance to the next slide, please, Ravi. So they established a controlled test bed to prove out the technologies that are critical for these reactors long term. So they created a relatively simple, as you can see, the control unit and test bed on the right, and is small. But as you know, the control technologies to control a small process and a large process are the same basic technologies. So starting with the PNID, they have a couple of different loops. The power generation, if you see on the left side, the heater, instead of doing this with nuclear power, they're using electrical power as the heating source. But to maintain as much of the feel of a real nuclear reactor, the control rods is a actuator that its position determines how fast the nuclear reaction is happening and how much heat is generated by the reactor. So in this case, the position of that control rod affects the power generation from the electrical to the heater. So they try to make this as realistic as possible without exposing the students to dealing with nuclear sources for the research here. This particular test bed, not yet, stay focused on the one before, Robbie, if you would, please. Yes, there you go. Okay, so this test bed uses water, but just to assure you, A&M is also quite active in the areas of molten salt and other aspects of the nuclear generation. But this particular test bed is strictly focused on the control aspect of it. And on the right, the picture of the system, the black cabinet is the COPA 500, the control systems. The rest of it is the process and the electrical connections. Okay, now to the next one, Robbie. So having designed the experiment, the next question was, well, what control system are we going to use? I mean, there's a variety of standard control systems available out there, but they wanted something that was modern, open, and could be the very best at helping them reach their research objectives with cybersecurity, reliability, rapid iteration of the design, so they can make changes, test them out, do modeling, and iterate over and over again. So that was important to them, to have high compute and data capability, remote management capabilities for it. And so when it all boiled down, the COPA 500 was an obvious choice. The stall IO is very flexible and proven. The code assist control is a de facto standard for IEC 61131. The ignition HMI also very well established and from a good company with good support. The ASRock industrial computer, and this leverages all off-the-shelf type of technology. So these components are not expensive, especially compared to a DCS vendor or even the normal smaller PLC system suppliers. A Supermicro, terrific capabilities as far as the computer. The OCF communications platform, or technology, which is a particular implementation of OPC UA related to open process automation. C-Flame provided this system management, which is what makes the whole system work and makes it reliable and practical long-term for support, and a Cisco switch. A nice package. So, okay, now if we can go to the next slide, Robbie. Okay. And this is just, we won't belabor this, but this is the exact models of the stall equipment that we chose for the IO. It met our project needs well and very flexible. So next slide, Robbie. I know you'll talk more about that later. And so this identifies the COPA 500, a typical small system design, the components and where those reside. Like the bottom black sort of box there is that's the main compute for advanced process control and modeling. The stall equipment is there sort of in the middle, the orange and blue chunks there that handles the interface to the real world. On that next rail above that, the DCN, the ASRock is on the right side. As you're looking at it, on the right side, power supply, switch is all there. And it makes for a very nice system. And it's fully integrated. That was a particularly interest to us. We weren't interested in researching how to build an OPA system. We were interested in researching what it can do and how you can use it best. So the COPA 500 provided a really nice package of a fully integrated OPA product. And it's we know that it's already been pre-integrated and tested. And so it is a robust implementation of OPA. We wanted to give OPA a really good chance to show what it can do. And we didn't want it to be hampered by our misapplication or missing something or overdoing or underdoing something. Okay, so now, Ravi, if you, I'll pass it back over to you.
Thank you. And here we go. Give you all a brief background about STAL in case you don't know, and also on the IOs particularly, how it is available with the OPA solutions. Yeah, so we are founded in 1876. I may look old, but I'm not that old. It's companies with a lot of the electronics involvement, electrical products, and then we also do and build complete solutions in the sense that in the IECX ATEX world, they need a certified workshop who can do it. Here in the NEC world, you have the UL 698A and all, which allows you to build and certify the complete solution. We can also do trainings, and then we also do hazardous area evaluations and services related to that. Based in Germany and accessible all over the world, somewhere around 18 operating subsidiaries, and beyond that, about 59-60 offices. 2024, we closed 344.1 million euros with 1,743 employees across the globe. Small company, small but nimble. We were able to learn the opportunities of these new or emerging technologies and be part of it. We are available across a complete portfolio of the electrical, lighting, and hazardous area automation products. It is good enough certified for NEC, ATEX, and IECX. So triple certified, nearly 95% of the products, maybe a few percent where we may need two different products to satisfy the individual certification requirements. That's what we call the automation wall. We have your barrier isolators over here, the IOs, and then we have Ethernet APL switches, and then the power supply for that, wireless access points, fiber optics for hazardous area. Yes, fiber optics also in the hazardous area can be a source of ignition because it is a concentrated form of energy. So you need to be careful there. control solutions, purge, grounding devices, again, handling the static energy that comes into play when you're transferring raw material from one tank to another, HMIs, and then the cameras for monitoring the process areas. So we nearly fit into the control layer and then the field device level. We've been doing this for the last 30 years. In fact, the iteration from 2000 onwards has been consistently the same. So you have I would say a very good form fit factor, which allows you easy replacements. Very early in the 1997, we implemented the Profibus DP RS485 standard, which we then donated to the Profibus International Organization. We were the first to use in 2009 the fiber optic OPIS standard, which allows us to run fiber optics into hazardous area without a conduit, just a regular fiber optics, maybe an armored cable. And we are now getting ready for the next 30 years over the span of next few years when the technologies evolve and we are ready with the way forward on what the industry is looking for. That's what I was talking about. So this was the old versions, if I can call them, from 2000 onwards, and this is the latest version. You can see the DIN rail and the bus rail remains the same. The I/O modules here with the red handle, I can remove this one, put a new one in, and it runs in a minimum capability mode. The CPUs, the form fit factor, and the connection to the bus rail remains the same. So you can replace an old CPU power supply combination with a new CPU and still run the old I/O modules if you would like. So a lot of combinations available. The Zone 1, Div 1 devices are certified as such. Because they are certified, you don't need a purged enclosure, you don't need an explosion-proof enclosure. You can put it in a standard NEMA 4X or an EXE enclosure. These are all intrinsic safe communication bus in the back, so you can implement hot swapping. And then, of course, the flexibility of using either detachable terminals and screwed terminals over there. That's the socket. If you would like to have, from the perspective of 3-slot, but also a 4-slot, more importantly, you have the capability to select protocols here. Specifically, if you're using it as a remote I/O connected to the traditional PLC and DCS networks over Profibus, Profinet, Modbus TCP/IP, Modbus RTU, or Ethernet IP, you can select the port over here. And then if you have the RS485, you can select the addresses over here. That's how simple and easy it is. Good enough for -40 to 167 degrees Fahrenheit or 75 degrees C installation. You can use either this 3-slot version or the 4-slot version on your right, where you will have redundant CPU and redundant power supply as well. The IOs, some very good features over there. We all know that project engineering goes until the time you have installed and commissioned your panel. At the last minute, you always have a requirement of one additional input or one wire is going in another panel and not in this panel. So very flexible, multifunction, configurable I/O signals. The discrete or the digital I/O module, I can configure it as input, output, NAMO, discrete inputs, whatever I like. The analog input module, I can configure it as input, output, 4 to 20, 0 to 20, with heart, without heart, with alarms. I can also have a temperature module, which can be either an RTD or a thermocouple or a PT100. So you could configure these if you have them as spare channels, and then you can configure them uh, at a late stage of your project as you go along and you realize you need to add something more. The temperature ratings are minus 40 F to 167 F or 75 C. At that high temperature, you are now able to offer an extended lifetime because the electronics is much more capable. This 15-year is just a theoretical calculation. We have customers with 25, 30 years installation who say, hey, this is working reliably and I don't want to change it. I definitely don't have a happy sales team who would love to have customers buying products day in and day out. But then that is not Stahl's philosophy. We would definitely like the customers to have a low total cost of ownership. Additional status information. This is very, very creative, if I can say, that it is able to detect that, hey, I'm running in an extreme temperature beyond the spec, or I was supposed to have 1 million on off states, and now you're crossing that 1 million on off states. This all could affect my electronics life, and I'm giving you an alarm 1 year before I drop dead and let you know, hey, keep a spare ready, plan a shutdown so that you can replace me without having to do a unplanned shutdown. So that's a very good feature. We talked about artificial intelligence or machine learning. This is something of where the electronics inside with the sensors are realizing what is the environment around it, how good it is and how bad it is and how it is going to affect its lifetime. So that's really a very good feature. Enhanced diagnostics. Each of the IO channels have the capabilities of line fault detect. So if your field signals from the IO terminal to the field device are broken or short circuit, you will get a local alarm, a red LED over here, and also an alarm on your asset manager or on your HMIs. The devices are optimized for zone 1, zone 2. Basically, you are able to do 16 channels per discrete module and 8 channels per analog or temperature module, especially if there are 2 wires. 100% backward compatible, and then of course it's very much cost efficient because of the high IO density. That's the range for the Zone 1, Div 1 hot swappable IO modules, intrinsically safe outputs. These are the 4 and 8 channel versions because they have to drive a lot of power. But then I have the digital input output, which is soft configurable. I can configure it as input or output. The 16 channel version, the analog universal, the temperature. This is an interesting digital output module with a solenoid valve built into it. So I don't need a separate valve station. I don't need a separate IO station. I can run it on the same remote IO station or an extended IO station. And this would be your output to drive high voltage, high current capabilities. Same for zone 2, div 2. The only advantage here is that I have non-incentive or non-intrinsically safe inputs available here. So you, in our world here in Div 2, in the NEC Div 2 world, end users would prefer to use a non-intrinsically safe or non-incentive field devices, and the IOs are capable of such an interface. For the non-intrinsically safe or the non-incentive IO modules and field devices, we can offer IO redundancy like we had for the CPU redundancy. One major capability is that these IO modules are talking to the CPU, so you actually don't have to go to the DCS CPU or the PLC CPU. The IO CPU is voting where to take the data from if one drops dead and the second takes over. And then it is also alerting you in at the HMI or the alarm manager that, hey, one of the IO modules is dead, you better replace it. A sample construction, especially I wanted to show you this valve island and the IO island all together. It's a Div 1 installation. This is the only conduit here, and then this is the complete enclosure in a NEMA 4X. Again, here the IS and the non-IS and a different construction in a 1200 by 1000 you could do anywhere between 128 signals to 256 signals. Okay, that was all about the IOs, but what are we doing for OPAs? So, with the newer hardware and the capability to have an open OS system like Linux, we were able to implement 3 versions. We have this DCN IO, which only has an OPC UA based OPA server. It talks the open communication framework or the open connectivity framework information model, which can then be accessed by the DCN computer or the ACP. So that is acting like a remote IO, but not with the traditional Profibus, Profinet, Ethernet IP, but with OPA server. This is the -40 version. Then we also have the capability to embed the IEC 61131, in this case codices, which you can implement, which is part of the OPA's group. And then you could also implement IEC 61499 runtime, which is the universal automation, which is nothing but distributed control or an event-driven based programming, unlike the IEC 61131, which is a sequence-driven programming standard. Though the languages in 61499 are similar to what you use in 61131. The 61131 standard, as you would all know, is the same standard that is used by most of all the PLC companies for their IDE, for their engineering tool. It is only that they customize it, add some value add features, and then customize it for their hardware. So if you do know any of the ladder programming function blocks or sequential function blocks and all that, you could still do those programmings on a Codesys platform or on a 61499 UAO platform. OPAS has been in play since 2016, 2017, since the association with Open Group. ExxonMobil built the first test bed and has also implemented the first lighthouse. That's what you see is an image of one of the IO panels. 90% of the IO counts were with STARS IS1 Plus extended IO, and the selection of the IOs was by the plant, by the actual user who wanted a more sturdy G3 compliant configurable IO where they have all those flexibilities like the flexibility OPAS standard provides. So that is what is now running since 2024. Some of the other test beds which were built by Schneider, which were built by Intel and demonstrated at the NAMO General Assembly in 2023. What we see as an opportunity, and this is for the embedded solutions, which I talked about earlier. And of course, there are the OPA solutions as well, the OPA server solutions. You could do migration greenfield from legacy systems in a div to zone 1 projects. A lot of you are providing support or are international companies where you would be deploying projects in the ATEX IECX world, so we could support you here. Ideally 100 to 150 IO points. Please note this is not good for safety systems or fire and gas systems. OPAF doesn't cover safety. It is only limited to the control system. And then additionally, same styles IOs are not rated for safety. Not good enough for robotic machine control or a conveying system. It is good for a process industry application. So again, please be aware of these limitations from a perspective of using our hardware. I get back to Tim, and he shares with you the current status of the Texas A&M project. All yours, Tim. I'll continue to scroll through as you tell me.
Okay, I do appreciate that, Robbie. Yes, and I appreciate your comments about point counts, like 100, 150 point counts and such. Just to be sure the audience is clear on this, OPAS, open process automation systems, can scale way beyond that, up to large systems, what people would normally think of as a DCS type of application. So it's a highly scalable system, with the distributed DCNs, each DCN handling its particular area, geographical or functional area where that's been assigned. So for A&M, this application, this was one of the smaller applications. And also from a systems integrator perspective, it is the open process automation, particularly as it scales to larger systems. The system integrator role varies from what traditionally it might have been. When you get into the size of like the DCS type size of systems and such, oftentimes the supplier, the vendor, would sort of politely nudge the system integrator out of the way and take responsibility for the entire system and require that in order for them to guarantee and warrant their system. But now with OPA, the systems integrator is in a really good position all the way through the project, because he's an extension. If he's doing his job well, he's an extension of the end user. That's just a knowledgeable extension of them, and it becomes a very trusted part of their company, even though he's not physically in the company. So I have clients that we've been working with for well over 30 years, and it's because of that relationship and trust. Now at A&M on this, the OPA, what we where the status is right now is the test bed is complete, the control system is connected, they're developing the control applications now against a digital twin. They're quite happy with the system. The ability to rapidly iterate has been demonstrated, and that they can choose whatever tool works best for them and their particular application. Python, MATLAB, skill sets that recent graduates and researchers have developed as a part of their normal course development and learning. So this OPA fits really well with those. They don't have to conform to a specific vendor's rigid, here's how you talk to us, and you won't talk any other way. The tools and libraries there is still some maturing happening. It doesn't affect the functionality directly, the core functionality, but I see that the tools, the suppliers continue to enhance and improve the libraries and tools. So it's not as mature as, say, a DCS or one of the other PLCs that is very slow moving. So there's the positive part of this is it's a very fast to develop. In particular, I want to also add that while it's a solid technology, which with application to many projects, it offers a lower cost than conventional approaches, even on the small scales, which was surprising. It was eye-opening to me. And it is seeing good acceptance with the end user community. At ARC, it was very well received at ARC by the end users there. They were excited by the progress that some of the early adopters were seeing and the success they were having. There are some new concepts. As a systems integrator, there are some new concepts, such as the GDS and the OCF communications, how those are done, how those are configured, and how they are intelligent enough that sometimes you, as a systems integrator, you think, I've got to configure this down to the last detail. But the GDS and the OCF handle a lot of the communication and that you would normally do. It just sort of works in the background. Someone like a Macintosh versus a Windows a few decades ago, where the Mac just works, where the Windows required lots of attention. But as we hit those, COPA and Stahl both been very supportive and rapidly addressed any information gaps where we didn't understand the system fully, or A&M did not. The flexibility of the Stahl I/O, Ravi presented that very well. That was a selling point for the choice of them. Out of other suppliers that could have provided the I/O, Stahl offered a particularly attractive package, because at the time we were designing the system, A&M didn't know exactly what type of sensors and what type of signals they'd be using. The fact that the thermocouple card can handle all the different types of thermocouples, RTDs, was a plus. That the digital I/O could be configured input, output, whatever. That was all a plus. From the system, one of the things we did learn as a systems integrator since you're taking responsibility for the system, it's very important that you understand and reduce the risk of, have I got everything I need in this price? And when we estimate, here's how much this is going to cost. The COPA 500 provided a particularly attractive package in that we didn't have to worry, do I have everything I need in there? Have I missed a component? Have I missed some software package or anything? It was all there. That was a plus from a systems integrator perspective. And long term, as cybersecurity, because threats are continuously emerging. This isn't like a normal world where you put in a system and you're not going to change it for 30 years. You put in a system today, it is likely to have cybersecurity initiatives that need to be rolled out to it at some point. The fact that we're working with COPA, we know that they have already verified and tested the cybersecurity initiatives that need to be rolled out, so to flush out any incompatibilities and make sure everything is smooth. So that was a big learning thing from our perspective, to realize this is a little bit of a different world. If you can go to the next slide now, Robbie. Okay. These are some of the higher level control that's being done in the compute package. And it is things that A&M is looking at regarding autonomous control. And since most systems integrators don't really get into this, but trust me, there is a lot going on in the world of autonomous control and the development there, that the researchers love the capabilities of the system. If you'll go to the next slide, Robbie. So this is sort of where we sit right now. The system is installed, and it has put A&M in a great position to continue their research into a variety of autonomous control technologies, and is helping them address the critical aspects of SMR, small modular reactor control, enabling faster and better development of clean nuclear power, which is to benefit of us all. That's where we are today. We've had some wonderful learning opportunities during this. COPA and Stahl have always been there to provide good support and help us with any area where we had a little information gap that we needed to properly apply the system. And that's it for me.
Thank you, Timothy. These are our contact details. We would be happy to receive any inputs from you. And if there are Any questions right now or later?
So I do
Yes.
have a couple questions. Sorry, I'm butting in. A
No
couple
worries.
questions came in from the audience. You may have addressed them, but just to be perfectly clear, the first question is, can other I/O module vendors other than Stahl be used with OPA?
Yeah,
Yes.
definitely
Yeah.
possible. It is a matter of asking your preferred vendor if they are OPAF aligned or they have the OPAF certification, which will come in place soon. From a COPA membership, yes, there is Phoenix already there and Star, but typically down the way, it will be an open platform for other IO vendors also.
Mhm.
Another
Yes, and we
question that,
have,
go ahead.
go ahead. I was just going to say we have in some of our other projects, we have actually used the Phoenix contacts since they are a part of the ecosystem. We have used them in the past. But this particular project, Stahl, just the flexibility built into their package was really attractive. And so we went with Stahl for this one.
So this one might be a little bit out of context because it came in while you were talking about something else, but it says, what are they using for digital twin?
Ah,
Oh,
okay.
that is for Texas A&M. Yeah.
Yes, yes. That is that is where we passed it over to A&M, and they're the ones that that are actually doing that. Otherwise, I would just tell you what they're doing, but because it is a university, so they are very open about what they're doing. This is not like, oh, this is proprietary, they're not going to tell anybody. It's just that I don't have the ability to answer it clearly. But if someone will reach out to me, I can get them in contact with A&M researchers to answer that question for them.
Awesome. So I have one final question before we do the final slides, and that is, as system integrators, what do we need to get started?
Well, the first thing definitely is to build a test bed.
Yeah.
As I would say, get your hands dirty, experience the technology, experience the plug and play. And once you are sold out, then of course, you'll never go back to a legacy system. At least that is what OPAP is all about. And I'm
Mhm.
sure that will give you that confidence to also talk to your customers about it. So building a test bed will be the first step over there. And you can join COPA, you can join OPAF, and you can learn more of the technologies. You can share your stories, what experiences you have from the test bed or otherwise, and we would be happy to take those inputs in and incorporate.
Awesome,
Mhm.
thank you. All right, so I'm just gonna wrap things up here. My colleague will put up some slides for me as I go through my last little bit here.
Thank
On behalf
you.
of go ahead.
No, I said thank you from our side. Yeah.
On behalf of CSIA, I would like to thank our speakers, Ravi and Timothy, for this informative discussion, and thank you to R Stall for sponsoring the event. And of course, thank you for attending. And that's a wrap. Please bookmark the CSIA events calendar so you don't miss any upcoming events, and have a great day.
Thank you again.
Thank you.